Hello everyone. In this video, we will explore the world of entity relationship or diagram notation. Diagrams are visual tools used in database design to represent the structure of a database. They help us understand how different pieces of information, called entities, relate to each other. Let's learn about the symbols and notations used in these diagrams, so we can effectively design and understand databases. Let's start with entities. Entities are real-world objects that exist independently. Think of them as the main subjects about which we want to store information in our database. In diagrams, entities are represented as rectangles. There are generally two types of entities. One, strong entities which have their own unique identifier, and two, weak entities which depend on another entity for their identification. Some common examples of entities include students, courses, and employees. An entity set is a collection of similar types of entities. Now let's discuss attributes. Attributes are properties or characteristics that describe an entity. They provide details about the entities in our database. There are several types of attributes, including simple, composite, key, derived, and multi-valued attributes. A simple attribute cannot be divided further, such as an age. A composite attribute can be divided into smaller parts, such as an address that can be split into street, city, and zip code. A key attribute uniquely identifies an entity, for example, a student ID. A derived attribute is one whose value is calculated from other attributes, like age derived from date of birth, and a multi-valued attribute can have multiple values, such as phone numbers. Let's examine relationships. Relationships define how entities are related to each other in a database. They represent associations between two or more entities. There are several types of relationships, including a simple relationship involving two entities. A weak relationship involves a weak entity and its related strong entity. Relationships also have cardinality constraints. 1-to-1 indicates that one entity is related to exactly one other entity. 1-to-many indicates that one entity can be related to multiple entities, and many-to-many indicates that multiple entities can be related to multiple other entities. Relationships can be binary, involving two entities, or ternary, involving three entities. Cardinality and participation constraints define the number of instances of one entity that can be related to a single instance of another entity. There are several notations to represent cardinality in diagrams. The Chen notation uses numbers and letters like 1, m, and n near the relationship lines to denote the cardinality. Crow's foot notation uses symbols at the end of relationship lines, with a crow's foot representing many. Min-max notation uses minimum and maximum pairs in parentheses, such as 0, n, to show participation limits. UML notation uses multiplicity expressions such as 1 or 0 double, asterisk to define cardinality. Now let's explore specialization and generalization. These concepts relate to inheritance in diagrams. Specialization is the process of defining subclasses of an entity type, where each subclass has distinct attributes or relationships. Generalization is the reverse process, where common characteristics are abstracted from a set of entity types to create a more general entity type. Inheritance is typically shown with a triangle or arrow, pointing from the subclass to the superclass, indicating an is a relationship. Let's dive into the Enhanced Entity Relationship Model. The model includes advanced concepts and notations that extend the basic model. Key extensions include subclasses and superclasses that represent hierarchical relationships between entities with inheritance. Specialization and generalization offer top-down and bottom-up approaches to defining entity hierarchies. A category or union type represents a collection of objects that belong to different entity types, and attributes and relationship inheritance allows subclasses to inherit properties from their superclasses. Let's recap the key concepts of diagram notation. Entities represent real-world objects. Attributes describe properties of entities and relationships. Relationships represent associations between entities. Cardinality specifies the number of entity instances in a relationship, and specialization and generalization represent inheritance hierarchies. We represent these using rectangles for entities, ellipses for attributes, diamonds for relationships, and triangles for inheritance. These notations help us visually represent database structures. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.